All right, people, it's the last 5 problems. Are you ready? So what we have is a new problem that states find the interest rate, which means when we look at our formula, we're going to be solving for something on the inside. You can't see. We're going to be solving for something on the inside of those parentheses because I want to know what rate to use. So we're just going to have to knock stuff off. So find the interest rate to the nearest hundredth of a percent that will produce 2,500. So that's the amount I want to achieve. Okay, if I'm starting with $2,000, which is my principal, okay, and it's compounded semi-annual, I said it again, semi-annually, which is twice per year for 4.5 years. Okay, so here's what I want. I want A equals P times 1 plus R over N raised to the NT. I want 2,500. I've got 2,000. I've got 1 plus R over N, N is 2, raised to the NT, which is 2 times 4.5. Okay, so what do I know? First of all, let's clean this up just a little bit. This can change into a 9, and I stupidly started writing with very little room to write left. So if I'm trying to get to this R, I need to get rid of this 2,000. Okay, so I'm going to divide both sides by 2,000. So divide him by 2,000. So 2,500 divided by 2,000 should be 12.5, which is 1.25. All right, so 1.25 equals 1 plus R over 2 raised to the 9th power. Okay, so what I want is to get rid of these parentheses so I can get to the R. I can't get rid of those parentheses until that 9 is gone. So what I've got at this point is a 1.25. 1.25 equals 1 plus R over N, which is 2, raised to the 9th. So I'm going to take a 9th root of both sides. And a way I can do that is instead of taking a 9th root of both sides is I'm going to raise both sides to the 1/9. Okay, so I'm going to use a different color pen so you can see a little bit better. I'm going to raise this side to the 1/9. So a power to a power means I multiply. So I would get 9/9, which is 1. And I'm going to raise this side to the 1/9. So in my calculator, I've got 1.25 raised to the parentheses, okay, 1/9. Make sure you use parentheses, otherwise it's going to raise it to the first and divide everything by 9. Okay, so I get a 1.025, 103. So 1.025, 103, 648. 648 equals 1 plus R over 2. Okay, so I got rid of those parentheses. Now I'm going to subtract 1. So subtract 1 from both sides gives me 0.025103648 equals R over 2. And now if something is being divided by 2, how do I kill it? I multiply both sides by 2. So now I'll know what R is. So I'm going to subtract 1 and then times 2. And I get 0.050207. 0.050207, and so on and so on. And I'm rounding it in percent format. So remember, this is decimal format, and I want it to the nearest thousandth. So move your decimal twice to the right, and I get 5.0207%. And I want it to the nearest thousandth, which is the 3rd spot. So that is going to be 5.021%. All right, so we have, find the number of years that it's going to take 9,700 to grow to 17,800 at 5% compounded quarterly. Okay, so how many years? So I'm trying to find years, which means now I really am going to have to go into log world. So I've got 1 plus r over n raised to the nt. So I'm starting with 9,700. I want 17.8. So I want 17.8, starting with 97. 1 plus my rate is 5%, which is 0.5, or 0.05, sorry. Quarterly means 4 times per year. And then I'm trying to solve for how many years. So that's going to be a 4t. So notice that what we're trying to solve for is up in the air. It is part of the exponent. So I'm going to start chipping stuff away. This 9,700 can go to the other side by division. So it's connected with multiplication, so we remove it by division. So I've got 17,800 divided by 9,700 is 1.83505, 1.83505. 1546. 1546 equals 1 plus, and then I've got 0.05 divided by 4. So 1 plus 0.05 over 4 gives me 0125 raised to the 4t. So I just went ahead and added this stuff in the parentheses. So this is now gone. So the only thing that this exponent is attached to is the 1.0125, which means I can now go into log world so that I can get that exponent down in order to manipulate it. So I don't care which log you use as long as you're consistent. So I like the natural log, so I'm going to take the natural log of both sides. Raised to the 4t. So this line and this line are identical, except for I took the natural log of both sides. So if I'm in log world, the exponent can drop down as a coefficient. So I've got the natural log of 1.835051546 equals 4t times the natural log of 1.0125. So this says 4 times t times the natural log of 1.0125. So I'm going to divide both sides by 4 natural log of 10125, natural log of 1.0125 with a 4. Okay, and now I'm going to, so any number divided by itself is 1, any number divided by itself is 1, so that gives me t. Now when I put this in my calculator, I'm going to put this in parentheses, because order of operations, it's going to see natural log divided by 4 times. So you've got to tell it that this is your denominator. So in my calculator, I've got the natural log of, oops, sorry, that's not a 1, 1.835051546 divided by, and then I'm going to put parentheses, and I'm going to divide it by 4 times the natural log of 1.0125. Close the natural log and close the denominator. And I'm going to hit enter, and it's going to say 12.217 years. So 12.217 years. Okay? So let's do a couple more. The growth and population of a city can be seen using the following formula. So I have the population in terms of time is going to be 1672 times e to the 0.003t, where t is the number of years since 1941. So use this formula to calculate the population in 1951. So if 1941 is 0, then 1951 must be 10. There's only one variable over here, and it's where t is. So I'm going to put in a 10 in place of t. So I've got 1672 times e to the 0.003 times 10. And now we're going to make our calculator do this work. So I've got 1672 times e to the, and notice when I hit e to the, it opens up a set of parentheses. So I'm going to say 0.003 times 10, and I'm going to close that exponent and then I'm going to hit enter. And it's going to say, okay, it's going to take me about 1,723 years to, I was seeing how far I had to nearest whole number, so 1723 years. I'm sorry, we're not doing years. All right, that's what the population growth is going to be. In 10 years, the population will grow from 1,672, and it will end up at 1,723, depending on if we're measuring in millions or billions or whatever. All right, so let's do it again. So we didn't need logs for that. So the growth in population of a city can be seen using the formula P of t equals 9983 e to the 0.006 t. And the question is, t is the number of years since 1970. According to this formula, how many years will it take for the population to double its 1970 value? So if this is the 1970 value, because if e is 0, e to the 0 is 1, times this is 9883. I want to double this. So I need to know how much I want to achieve. So 9983 times 2 is going to give me 19,966. Equals 9983 e to the 0.06 t. Okay, so now I'm trying to get this t by itself. So I'm going to divide both sides by 9983 because I got to get rid of everything that is not attached to that exponent. So now look at this magic. When I divide this, divided by 9983, I get 2. Okay, so I've got 2 equals e to the 0.006 t. So what this says is I had 100%, or I had one whole amount, and I doubled it. So I really didn't have to do all this figuring up here if I knew that to begin with. In other words, if I wanted to triple it, I would just say that this is 3 and this is 1. If I wanted to half it, I would say that this is half and this is 1. Okay? So now the only thing that this exponent is attached to is the e. Since natural log deals with e's, I'm going to go ahead and use the natural log. So I've got the natural log of 2 equals the natural log of e raised to the 0.006 t. And now that I'm in log world, I can drop this down. So the natural log of 2 equals the natural log of 0.006 t times the natural log of e. Now, hopefully, you've caught on to the fact that the natural log of e equals 1. And that goes back to what we studied like 2 sections ago. But if you haven't, then I'm trying to get t by itself. So I'm going to divide both sides by 0.006 times the natural log of e. But what I would do is I would say the natural log of e equals 1. And that's in the notes that I gave you, by the way. So I could just say, well, forget that, okay? And then I wouldn't need to divide it away because it'd be gone. So at this point, my answer, now I'm going to write it cleaned up a little bit because I just destroyed everything. 0.006 equals t. So I've got the natural log of 2 divided by 0.006 is going to give me 115.5. So I've got 115.5 is that many years for the population to double. All right, so we are going to find out this last problem. So the growth of bacteria makes it necessary to time date some food products so that they will be sold and consumed before the bacteria count is too high. Suppose for a certain product the number of bacteria present is given by f of t, so it's a function of time, equals 600 e to the 0.1 t. Okay, t is time in days, so t is in days. The only time that really matters, that it has to be years, is when you're dealing with money. Okay, and the value of f of t is in millions. So f of t is millions of bacteria. find the number of bacteria present each time. So for A, we've got 2 days. For B, we've got 4 days. And for C, we've got 1 week, which you should remember is 7 days because we're measuring in days. So I am going to f of t equals 600 e to the 0.1 times 2. So I've got 600 e to the 0.1 times 2. And I have 732.8 bacteria, nearest integer. So 733 bacteria. Million bacteria. Okay, for 4 days. So I've got 600 e to the 0.1 times 4. And I get 895. 895 bacteria. $895 million bacteria. And then after a week, we have f of t equals 600 e to the 0.1 times 7. So 600 e to the 0.1 times 7. And that gives me 1,208 million bacteria, which is 1.208 billion bacteria. And that, my friends, is it for college algebra. So it's been fun, and I will see you later.